So these are the videos for notes for 8.4, which are graphing quadratic functions using transformation. First, let's talk about what a transformation is. A transformation can be a whole group of things. It could be a translation. And a translation is basically a movement or a slide or a shift, whether it can be horizontal, left or right, or vertical, up or down. Also, it could be a stretch or a shrink, which just tells us that the graph is getting wider or more narrow. It could also be a rotation, which is more like a flip. Okay, so those are just some examples of transformations. The ones we're really going to be dealing with would probably be the first two translations, which is a slide or a shift, and a stretch or a shrink. So if you go ahead and do this warm-up right now, recall that these are equations of a linear equation. So this is y equals mx plus b. This is a line. And recall that our slope is 2, which is our m value, and our b is -1, which is our y-intercept. So if we were to go ahead and graph this right here, go ahead and do that now. And you can pause it, and you can come back. So recall that when we graph an equation, a linear equation, we're going to start at our y-intercept, which is our b value. And this number outside tells us that we're moving either up or down. So right here, we're going to start at our y-intercept at -1. And from there, our slope tells us to move 2 units up and 1 unit right. So from our y-intercept, we're going to move up 2 and right 1. So we can go ahead and try and draw that straight line through it. That's how our line looks. Now if we go ahead and draw this line here, y equals 2x plus 3, again, we're going to start with our y-intercept or our b value, which is at +3. So on the y-axis, this tells us we're moving up 3 units. So 1, 2, 3. We're going to start here. And then our slope tells us that we're going to move from here up 2 more units and then right 1. So if we go ahead and connect those lines. Now it appears that these lines are parallel, and that's true because our slopes are both the same. And recall that in a linear equation, when you have slopes that are the same, the lines are in fact parallel. Okay? So what's really important to notice is that our b, or our term out here, told us which direction to move. So when we were adding 3, we moved up 3 units. When we were subtracting 1, we were moving down 1 unit. Okay, let's look here at this function. So we have an f of x equals x squared minus 4, and they want us to find the domain and range. So what's important to note that this is a quadratic type of function, and the shape of this graph is going to be a parabola. And there's a certain point here that is our lowest point of this parabola, and this is called our vertex. Okay? Now, the domain are the set of all inputs that I could put into this function for x. So if I were to input any number in the world, I'm not going to get any restrictions whatsoever. In fact, if I put any negative number, if I put any positive number, or even 0, I'm going to get some real answer as some real number as my answer. So therefore, the domain can be the set of all real numbers, and interval notation that would look the same as -infinity to +infinity. However, the range talks about our y value. The domain talks about our x value. Our y value, or our range, is basically saying, what can I put in here for y? What is the lowest y value and the highest y value that I get? So if you think about what I can insert in place of x, such that I'm going to get the lowest number I could possibly think of. If we think about that, if we put any positive number and square it, or even any negative number and square it, it's going to give me a positive answer. So what value for x can I input? Am I going to get the lowest possible answer? If I put a 0 in, 0 squared is 0, and that's the lowest I could input for x. So if I put 0 here and then minus 4, the lowest y value that I'm going to get in this whole graph is negative 4. So that means this vertex right here, my y value is going to be negative 4. That vertex right there is negative 4. So that means every other point on my graph is going to be increasing or greater than negative 4. So my range then are the set of all y values such that it has to be greater than or equal to negative 4. So in interval notation, I could write negative 4 all the way to positive infinity, and that's what my range is going to be. Okay? So if we go ahead and look at our function here, now this is actually used to seeing standard form, ax squared plus bx plus c equals 0 with standard form, but the fact that we have f of x now, that's just saying we do have a quadratic function instead of a quadratic equation. That's the only difference. Now remember, a, b, and c are real numbers, so those are our coefficients, and a cannot be 0, because if a were 0, then 0 times anything is 0, and we would not even have a quadratic term. So a cannot be 0, so you got to make sure you understand that. Okay? So we've already covered that the graph of y equals x squared is called a parabola. And a parabola is a U-shaped graph, and it could either be facing upward or it could be facing downward. Okay? So your general y equals x squared graph goes through the center or the origin and is shaped like a U and has arrowheads in both directions, stating that it's going up forever and ever. Okay? Now this point has a very specific name. In this case, this point is our vertex, which can be, depending on if you have a U-shape or an upside down U-shape, is either going to be the minimum or the maximum value of the function. Of the function, meaning of our y value. So that means our lowest point will be at the vertex, and that affects the y value. So the minimum is going to be our lowest point. So if we have a U-shaped, regular U, our vertex is going to be our lowest point. And if we have an upside down parabola, like this one over here, then our vertex is going to be our highest point, or our maximum value. Okay? So we're used to seeing an actual quadratic equation written in standard form, but now we're going to talk about a parabola in vertex form. Now this looks pretty odd, but vertex form is written where f of x equals a times the quantity x minus h squared plus k. K is actually just like our linear equation here, where it tells us our movement up or down vertically, okay? And notice that this h is included with our x value. That is actually going to predict the movement of our graph left or right horizontally. And so what this a does is that pretty much tells us which direction our parabola is going to open. Okay, now h comma k is the vertex. We will see some examples down here when we get to them on how that applies to these situations. So if our leading coefficient in front is positive, so if a is greater than 0 or positive, then the parabola opens up. So it opens up like that. And if a is less than 0, so if this is a negative number, then our parabola opens down. So it's opening like that. Okay? All right, so let's take a look at some examples. So if we use the graph of f of x equals x squared to graph the quadratic, notice that, again, that's our original graph that we put here going through the origin, and it's U-shaped parabolic going through all those points. So they want us to graph f of x equals x squared minus 3. So notice that this minus 3, just like our linear equation, is not attached with that x, and it tells us, okay, we're going to move down or up. And because this is minus 3, that tells me we're going to take our normal U-shaped graph and then just take that and move down 3 units. So all we're going to do is make a U-shaped starting at our y value at -3. And that's it. Now, how did we know it opened up? Because I have a leading coefficient here. Our a value is a positive 1 here. So when I have a positive 1, that means we're going to open up. Okay? So that's how I knew I was going to get a U shape like that. All right, let's look over here. So again, because this 1 is outside, in other words, it's not attached to the x, this tells us a movement vertically that we're